Hi, I'm Steven, developer advocate for Event Store. In the next few videos, we will dive deeper into event sourcing and see how an event source application works and the components it's made up of. In the first video, we will take a step back and review how traditional applications work. This way, we can compare how event source applications work in contrast. So without further ado, let's jump right into it.
Say there is a classical three-tier application with three layers. The UI layer that users interact with could be a mobile app for food delivery, or say a web page for a CRM system. The application layer is typically your web server, microservice, or serverless function that contains your business logic. And the database layer is where your data objects are stored. Typically, to write or make a change to the system, the user would first make a write request and submit some information through the UI. The UI layer would relay this to the application layer through a request that we call a command. A command represents a request for an action that can change or write to the system. An example of a command is a loan request to a bank. This action is expected to update the bank system and contains details such as who requested it and the loan amount. Once the application layer receives the command, it retrieves data related to the command and sends it to the business logic. The business logic then executes it by validating the existing data against it and updates the database with new data. This is traditionally how you make a change in a three-tier application. On the other hand, if a user wants to read from the system, the user would first make a read request and submit details through the UI. The UI layer would relay this to the application through a request that we call a query. A query represents a request to read data from the system. And while a command triggers a write to the system, a query triggers a read. An example of a query is to ask for information about a loan request. Unlike the loan request command, this will only read and is not expected to change anything in the system. Next, after the application layer receives the query, it gets data from the database, transforms it to something in the business logic, and returns it to the UI layer and back to the user. And this is basically how read and write typically works in a traditional application. While this traditional model is simple and comfortable for most business application developers, over-reliance on a single application and database can be troublesome in the long run. As an example, consider the command to request a loan. When a system is first designed, the application layer may only be responsible for saving the new loan request to the database. But as time goes by, the business user starts to request more enhancement to the loan request application. Some of these may require updates to external systems. In the context of this section, an external system is a third-party application that the system has to update due to some action. For example, when a loan is requested, it may need to send an email to the requester. It may need to call a third-party API, say update the credit bureau. Or maybe it needs to send a message to a message broker to integrate with other systems. Slowly, the application layer becomes more and more complex as increased functionality is required. On the other hand, the queries in the database were likely quite simple as well too when the system was first designed. However, as time goes by, more and more tables were added to the database to accommodate different business requirements, perhaps related to the loan request for other departments. For example, perhaps the loan request tables must be joined with invoice and payment tables to manage overdue payments, or it needs to be joined to risk assessment, like credit score history and collateral valuation, or it needs to be joined to marketing-related tables to track user behaviors over interactions with marketing website and EDM emails. Slowly, the database layer also becomes more complex as it queries with more nested joins across tables. And this is where event sourcing can help. In this video, you began to review how traditional applications work in order to understand how event sourcing works. You have reviewed the read and write process of a classical three-tier application with the UI, application, and database layers. You're introduced to the command pattern, a request for an action that can change or write to the system. You also were introduced to the query pattern, which is a request to read data from the system. Finally, you explored how over-reliance on this traditional model can be troublesome as the system takes on more responsibilities in the long run. The application layer may have to make increasingly more calls to external systems as it simultaneously processes a command. The database layer may have to deal with increasingly more nested joins in queries and stored procedures.
In the next module, we will look at how event sourcing works and how it handles command and write to the database. Enjoy, and see you in the next video.